So radical expression involves radicals. So where we can see an expression like that. So um, yes, this expression can we can use another way to compute it is using powers. It's a 1/n. So the rules of powers apply for radical expression. So if you have, for example, um, if we have um, a radical of EB of products, so you can just come back to the power using power, okay, the expression using power, then use operational powers. So you can have a power 1/n times b power 1/n. Then if you need to use radicals, then you come back to the definition, okay? Etc. We have also another expression, for example, of the ratio. So will be a over b 1/n, which is then yes, a power 1/n over b power 1/n, etc. A over squared come back to 0. Okay. And finally, the last one, let's add it here, square n. Um, and yes, again, a, but another power here. So we will have everything a 1/m power n, which will be a power, the product of mn, which we can use then radicals n times m of a. So this mainly, yes, the definition mainly we use the connection. Yes, sometimes we need um, to eliminate the radicals from, for example, if we have fraction, we want to eliminate to transform our expression, eliminate the radical from numerator or denominator. To do that, we use what we call conjugate expression. So what we call conjugate uh, of a plus b is a minus b. And you will see the effect if one of the terms e or b has a radical. When you do you you use it as a factor multiplying, there is something happening. You eliminate the root, okay, the radical. And yes, so it is used, so we use it for use it okay, use it for rationalizing an expression, rationalizing an expression, a radical expression, or an expression with radical, more precisely, an expression with a radical. So let's do the yes, some practice on that. Yes, what about, for example, an example? It's more that. Otherwise, you need just to compute, use your definition, okay, between these radical and the power. Okay, so yes, first example, rationalize the expression. Square root, the numerator, for example. Yes, we precisely the numerator. So let's rationalize the numerator. Square root, simple one, 17 over x square root. Okay. So I can separate. I see here, I can separate. So I can say it's square root of 17. I separate y because I'm asked to rationalize just the numerator. So I have a fraction. So I have, okay. And then I can multiply here by both sides by square root of 17, because here it is what will happen. The same square root of 17. Okay, I didn't modify my fraction, it's the same. I multiplied because I can simplify it at the same time. Okay, so now this expression will give me exactly 17. Okay, over, then I can regroup terms if I want here and tell like that. And now my numerator is rational number. Okay. What about if I have, this is first example. What about if I have an expression like this one, x2 plus 31 minus x, and the question is the same, rationalize the numerator. I can see this expression as a fraction by dividing by 1. Okay, so the idea is to use the conjugate expression. So the conjugate we said is, so how we will use it, we will multiply both uh, numerator and denominator by the same expression, the conjugate, x2 plus 31 plus x2 or square root of x2 plus 31 plus x. And then we will use what? We will use the identity, remember, a minus b times a plus b will give me e2 minus b2. Okay, so this is what we will use. So we'll get square root of x2 plus 31 square minus x square over the 1 times, so we get exactly the same here. And now let's need, because here let's go through the detail. Maybe here my expression, I can see it as, so x, maybe let's put it just a bracket here, one bracket here. So I have um, x2 plus 31. We have square root, okay? Square root, everything power 2. So I can write it as x2 plus 31 power 1 over 2. This is by definition here. Then everything power 2. But then we multiply the powers. So it will be x2 plus 31, 1 over 2 times 2, which gives me x2 plus 31 power 1, which is x2 plus 31. Okay, so we will have x2 plus 31 minus x2 over this denominator. And if you simplify, you get exactly x2 over square root of x2 plus 31 plus x, and like that we rationalize the numerator. Let's now see an example where we will rationalize the denominator. Okay, question, rationalize the denominator. Okay, so first let's do one like this one. For example, minus 2 plus x minus 7 over 6 square root of x minus the square root of 7. So we will proceed as we did in this second example. So we have a radical here in the denominator. We want to eliminate it. So we keep this constant for a moment. So I will multiply the numerator by the conjugate of the denominator. Conjugate is square root of this term especially. So I will just do that 6 times square root, keep this one, and I multiply this term. So I added this factor, so I need to do it. Now I use the identity we used before. So we will get x minus 7. We keep and change it as factors because our purpose is to rationalize the denominator. So I will get x square root of x square, which is x, and I will get minus square root 7 square, which is 7. And I can even simplify my expression. So I can simplify it by x minus 7. And finally, my expression is reduced to -2, okay, plus square root x plus square root 7 over 6. And we can keep the result like that, okay? Here is another, let's look at this other question. This time, again, the same. Purpose is to rationalize the denominator. So square root of x plus 4, sorry, not plus, it's minus 4 square root of y. So here I have two radicals, but still let's use just, okay, the conjugate expression of this expression with radicals. So it's plus 4 square root of y. So I multiply the same here, y. And here I see I have a difference of squares. This one, this term, if you look at it, this one, you can check that it is 16 square. So I can factor my expression as x minus 16 y times x plus 16y. Okay. Yes, then let's develop and see what we can get here. So I will have x minus 16y times x plus 16y, square root of x plus 4 square root of y, and the denominator here will be square root of x square, okay, minus 4 more 4 square square root of y square. But this exactly it's x minus 16y. Okay, I write it again. Okay, over. So I have x minus 16y. And I see I can simplify my expression by this term. Oh, sorry, not this one. This one with this one, and get a denominator 1. So, yeah, my fraction is rationalized.